It's space weather! We're appearing on camera today to thank all you new subscribers, all you people that are plugging our channel. Thanks a lot. We really appreciate that. Never expected to have so many subscribers and are completely overwhelmed by the outstanding comments. And it's fascinating. The reason we're on camera, though, is because we wanted to show you some of the preps that we're doing here. And first of all, got, see that there? There's 2 indoor tomatoes. But better yet, in this room we've got, check it out, an actual tomato growing in December. What happened was we have a compost situation going on outside, and some tomatoes just spontaneously sprouted. They must have been growing there for a solid month. And when the first freeze came, we decided we're not going to let them die. So we brought them inside, put them under grow lights, put them in pots, and put them on 12-hour cycles, and there you go. Within about 5 weeks, we got a tomato growing already. Interested to see what kind it is. It doesn't look like a plum. It looks like it's going to be one of these standard Pennsylvania vine tomatoes. So anyway, some interesting stuff there. Now let's get into space stuff and let me vanish. Looking at the sun at 304 angstroms. We have a little bit of ejecta in the southwestern limb, and a sunspot near the equator. Will it keep its umbra long enough to get named? Well, it's hard to say. That's not something to predict. Well, let's look at a different wavelength here so we can see the coronal hole situation. As we know, the sun is currently characterized mainly by said coronal holes. As the new one rotates in, the solar data is all over the place. Let's look at the magnetic fields. And similar to the solar data, the magnetic structure is all over the place. Now, there's a sunspot. But it may be too small. Let's take a better look. So here's the colorized magnetogram view on the SDO. And it looks like 2 sunspots may form. We're pretty sure this one is already a sunspot. Whoops. Pretty sure this one is already a sunspot as we see umbra in the intensity gram. And this one here, keeping an eye on that, that could be one soon. Now, what's so interesting about it? Rush lyrics. What's so interesting about Rush lyrics? Well, let's see. So, from the Moving Pictures album released in February 1981, their 8th studio recording, there's a song called Vital Signs, lyrics by Neil Peart. Apparently, maybe he's a cosmology nerd, I don't know. And what are we looking at here? A tired mind become a shapeshifter. Everybody need a mood lifter. Everybody need reverse polarity. Why are we talking about reverse polarity in Rush lyrics? Well, because of that. You see the polarity of this sunspot and the polarity of this sunspot. Those are not the same. Alright, we'll just leave it there. The people that know what we're talking about will get it, and the rest will not. Now, let's look at the earthquake situation over the last several hours, only to realize that once again there's been so many earthquakes that we're only getting 4 hours on the global incident map feed. So let's head to the USGS feed instead. By the way, we did look at the Schumann resonances in the most recent earthquakes, and we don't see a correlation there. Alright, so late last night, we did have 5.0 in Tonga. We're going back much farther than we usually do. Even later last night, a 4.7 in Tonga. That area has been a rockin'. And really, a lull in major activity is what we're seeing here. Let's just zoom in on those Tonga quakes, just to see what went on with those. I think that's the one. Yeah, there you go. And moving on, let's get rid of this app. And for those of you who are interested in Schumann resonances, we'll leave a link below to this page. We did notice a spike right here before some quake activity last night. But we're not convinced that this is any sort of an earthquake predicting thing, as I'm sure Ben Davidson would agree. Let's look at the geomagnetic perturbations here. There are some spikes in this, so let's just let it play through. There's North America. Got some significant magnetic perturbations there. Nothing too crazy. This is measured in nanotesla, by the way. And let's just look at the global one also. There's your global magnetic perturbations. Courtesy of University of Michigan Geospace Model V1.5. Let that play through once. And it looks like the recent uptick has subsided to some degree. Let's just go back to the SDO for one quick minute here. Anyway, we're trying to look at the intensity gram and see the umbra associated with this sunspot. And not an hour ago, we saw umbra there, and now we don't see any umbra. So maybe it's not a sunspot, but there is an interesting active region going on. Here's a zoom in at 171 angstroms. It's right in front of that coronal hole. And let's watch the animation of that to see its formation. We'll let that play through twice, once zoomed out and once zoomed in. Alright, if it's going to be a sunspot, it's going to be a baby. While we're here, get a great view of this ejecta on the southwestern limb. Looks like a missile shooting out of the sun. I'm not sure if it made it out of the corona. Let that play through again. I think some of it did eject. And that's probably visible on the LASCO C2. Let's check it out. You can see that old coronal mass ejection headed toward the Earth at the beginning of that. Interesting little haze coming toward the LASCO. No, little anomaly on the video, but you don't really see any ejecta from that. That might have stayed in the corona. Alright, so let's head to spaceweathernews.com, look at the details. X-ray flux is still flatlined. We do have a bit of a phi angle signal here. That's the coronal hole, still connected to the Earth. Earthquake risk continues. We got some big spikes in the BTBZ, and we know that a negative BZ is associated with earthquakes. So if you're in an earthquake-prone area, your risk continues. Have a plan, have a bug-out bag, etc. Solar wind density still below 10, and it looks like it's dropping off. And it looks like we've reached the peak in the solar wind speed, as now that is declining as well, marking an oncoming end to the current coronal hole wind stream. We're not expecting the one from the Earth-facing coronal hole for a couple of days. You can see some heavy spikes in the magnetometer the last few days. And, you know, the sun's visible magnetic field's obviously showing some perturbation. KP index down to 2. And we're still having a major electron flux dip. We're expecting this to end at the same time that this dip. We're expecting this not to be so low. So keeping an eye on that as the ionosphere is extremely discharged. And there's your F2 map. Nothing too anomalous there. Although the sun-facing portion is looking a little weak. There's your auroras. And let's head to a couple of articles here. This one from phys.org. And indeed, we will leave links. Astronomers detect low-mass brown dwarf around A-type main sequence star. In the quest for planets, they've discovered a brown dwarf orbiting a more normal star. And this is a pretty rare event. The brown dwarf is designated HATS-70b, which is rotating around HATS-70. Brown dwarfs, if you don't know, are intermediate objects between planets and stars. Astronomers guess that the mass range would be around 13 to 80 Jupiters. Not so sure on that, but hey, it's an interesting article. Again, we'll leave links below. Now let's look at some nonsense. Also from phys.org, turns out there's uneven levels of sea level rise, uneven rates of sea level rise. Must be tied to climate change. So this one came out yesterday, and it's nonsense. And of course, we're not seeing sea level rise. Anyway, we'll leave links to this article also. Now at least they are using altimeter data from satellites. That's one thing they got going for them. Because if you use buoys to measure sea level, or even if you use GPS based on the ground, sometimes the ground moves around, believe it or not. We've done a lot of research on this, hours and hours and hours of research on this. And the problem with measuring sea level is that the continents shift. Also, if the ice caps were really melting, the continents would actually flow toward the poles, believe it or not. Now, that looks a little odd, doesn't it? I mean, how come we're getting these large sea level rises, but then we're getting sea level drops also? Well, the reason is because not only does this have nothing to do with CO2, it has nothing to do with the planet warming. And since the planet's cooling, we're expecting sea levels to subside instead of rise. In order for it to rise the way these brilliant predictions are being put forth, we'd have to melt the ice caps, which is something probably not in the capacity of mankind in the first place. But all that aside, let's check the Arctic sea ice volume. See that black line? It doesn't look very melted. Let's look at the thickness here. What is that? Oh, what is that? 5 meters thick? 4.5 meters thick right there. 4.5 meters thick all around Greenland. New spots that are 4 meters thick. Right in the Northwest Passage. Yeah. Sorry, global warming alarmists. That's not melted. Let's look at Antarctica. Global Cryosphere Watch. Oh, what's going on with this? Maybe Antarctica's melting. All right, let's check. Come on, you can load. So apparently the Russians are looking at this stuff. Can't find a map with English writing on it. But yeah, there's the Antarctic ice. And the main colors there are just thickness. So yeah, no melting ice. I'd like to thank our endorsing channels and, you know, our channels that we endorse and channels that endorse us. Sky Scholar, Oppenheimer Ranch Project, Suspicious Observers, David Schlottower, and Adapt 2030. We'll be doing it again tomorrow. Now remember, when you're checking the polarity and umbra of a sunspot right on the solar equator, don't drink. And if you drink, check the umbra of a sunspot in the solar equator anyway to see if it's going to be called Sunspot 2729. And also, don't drink and drive.